Mhm. So I'll share my screenshot here. So can you see my screen?
Yeah, I can see your screen.
Okay. Okay. So yeah, this is going to take um it's going to go over basically this training or this our program is going to last for 13 weeks. Yeah.
Okay.
And this is like an idea of what we're going to be covering over that time. So you already know how to use AutoCAD, yes?
Yeah.
Okay.
Yeah. Yeah. Yeah.
Okay. What about Revit?
Yeah. Yeah.
Okay. What am I teaching you again now? Okay, basically, and then you know about um, you know some basic things about it. Okay, I mean I will talk about it as time passes, obviously. So yeah,
Okay.
in week one, we're going to talk. This is week one. We're going to talk about mechanical systems in buildings, HVAC, plumbing, and fire protection. Then we're going to talk about overview of project stages, which I believe you already have an idea of, but we'll still just dwell on it a little. And then software setup to confirm that you have like the necessary softwares you need. Then in week two, we go into HVAC, talk about thermal comfort. Yeah. ASHRAE is you probably know about this thing from university, refrigeration and heating, HVAC and refrigeration. I don't know if you learned it. Did you learn that?
Yeah. We did.
So there's this psychrometric chart that helps one to talk about the dry bulb temperature, wet bulb temperature, all those things, the cooling and the heating. Then sometimes also there's this where maybe there's return air, there's exhaust air, there's supply air, there's how they can be mixed and conditioned too, all those things. So actually, so you need to like brush up on this actually basically. Yeah, so actually I don't know if they really like Nigerian design really work with them, but the USPs actually is like one of the bodies that our designs must comply with. Basically. So you need to like have an understanding of what they are about. So yeah, um, so that then let's talk about cooling load and all those things. Then next week we'll talk about software. Um, the software is for calculating heating loads. So it's not enough to know about heating and cooling loads. You need to know how to determine how to estimate the loads. So that also helps in your sizing of your equipment. Then we talk more about the air quality and ventilation, basically. Then still you notice I see reference ASHRAE here too. So just take note of this ASHRAE chapters so I can read up on them and brush up on them. I hope you are noting these things I'm saying. Okay, okay. Because this actually I only need to like we are going when we come back to it, I wouldn't want to like dwell too much time on it. Then next we have HVAC equipment selection. So after sizing, we need to learn how to select the type of equipment needed for the space. So there's DX, VRF, chilled water, but the ones we're going to focus on are just ducted and mini splits. I mean, as time passes, you'll be able to like use the knowledge to like learn about more and all of that. Then this another criteria to take into consideration is the efficiency, which is the COP, coefficient of performance, and all those things. Um, then next, talk design. So this is not very common in Nigeria. Most times when you talk about ACs in Nigeria for residential places, it's mostly just mini split that comes to mind. So the only time you really use these dots is for big, large buildings like malls, maybe airports, maybe supermarkets, big maybe cinemas too. I don't know if, and as time passes, as you go into these places, you like be able to observe these things better, the different types of systems that are existing. You just see that you're able to like tell them apart more easily. And then in the US, basically, these systems are more commonly used than mini splits. The only times I use mini splits in my design is when the space is very small, or when the space is really small, because you don't need to like um anywhere you put the AC to see the heating or the cooling will still get to the whole space. Yeah. But in ducting is important when you need to like pour it in different, you need to like distribute it evenly to different, yeah, across a larger area. So you need to learn how to like lay it out and all of that. Then next week, the next week we're going to talk about water. This is your strong forte. So I won't be surprised if I don't need to dwell too much time here. So I'll just share what I know with you, and then you will share what you know with me, and then you understand the areas of intersection too. Then yeah, then by week eight, we are going to talk about fire protection. So unlike in Nigeria where people use their this thing, their major protection against fire is just fire extinguisher and then blood of Jesus. And then blood of Jesus. Yeah, it's true. Because most people don't take this into consideration. But in the US, for example, two things that two systems is the fire sprinklers and then the fire alarm systems. So these things help to like ensure that the building is sustainable or is safe for the use and for the occupants. So we'll learn about that too. Then we'll now go this week. We'll talk about the sprinkler system. Then this next week, and then this sprinkler system talk about, you will need to like brush up on your knowledge of piping. Yeah, your knowledge of plumbing will help you in this particular week. Yeah, in this particular area of sprinklers, because it's basically water flowing through pipe. Then a fire alarm. This one has some area of intersection with electrical. If you have an electrical engineer in your firm, you are lucky because you will not need to do all of this too much. But if you don't, yeah, you may need to like do a lot of this. Yeah. So, but it's nothing that you cannot research on. It's nothing too deep. Something that you can have basic understanding on and just routing and wiring. Then another thing that is useful in the US space is gas. Yeah. So unlike in Nigeria where it's only mostly gas turbines that use it, or large facilities that is for like electricity generation. Over in the US they have like gas networks. You know how your background is noisy. You know how in Nigeria we you know how in Nigeria we use everybody has their borehole. Yeah.
Yeah.
And their sockaway, their septic system too.
Yeah.
In the US, it's not like that in a lot of cases because there's like a general water network where people can tap off their water systems from, and then there's like a sewage system where
Okay.
people can tap into. So also
Okay.
they're in some areas, depending on how much gas they have, they also have such a system, but for gas. So
Okay.
yeah, so there are some equipment in the house that you run on gas. There are some HVAC equipment that run on gas. There are some anything that basically uses an engine or that uses like combustion to like work, or like, do you get maybe a pump or
Yeah, I
something.
get you.
They would need gas as their fuel to run on. So that is why you need to understand how to like plumb gas into the house. So and then it's also cheaper to use gas to power some of even your water heaters, your cooking equipment and all those things. It's cheaper to use gas than electricity. Electricity is just safer and it's more readily available, but on the long run, it's cheaper to use gas. If you had to choose between both of them, most times you choose gas because in the long run, the cost is less. Yeah.
Okay.
Mm-hmm.
Yeah.
Mm-hmm. So then the following week talk about Revit. Yeah, this week, luckily, because you know about Revit already, we want you to dwell too much time on this. I'll just teach you the little I know and then add it to what you know too. Then this week we'll review like your knowledge on ASHRAE. ASHRAE is usually necessary for your knowledge of HVAC, yeah, heating, ventilation, and air conditioning. Then NFPA is for fire protection systems, yeah. Then IPC is it stands for International Plumbing Code, and IMC stands for International Mechanical Code. There's also International Building Code. So this mechanical code is still like mechanical is HVAC. Basically, anytime you hear mechanical drawing, it's HVAC they're referring to. Mm-hmm. So they're referring to. So I mean there are like different states also. This one. There are different states. So this is international, means that it's like a national or it's like a universal method of designing. But in some certain states, they're like they have their own like separate codes. Yeah. And those codes are usually sometimes based off of the international codes. But you also need to know about those codes too, so that you can specify in your different drawings. If you get a project from a specific state, maybe Florida, Florida has its codes. If you get from Colorado or from California, they have their codes. Sometimes they are like areas of overlap, obviously, but you need to reference those specific codes and then you need to like check to ensure that whatever you're designing follows those specific codes. So you just need to you will get to understand those codes better and how to select which when all those things. Then you also will talk about how to coordinate with electrical, structural, and architectural. So I would like to ask about your team currently. I don't know how much you've known about them, but there's probably an architect. There's probably a structural. Yeah, there will be structural. There will be these different departments. Yeah.
That's for the basically projects that's
Mm,
like architectural
mm,
structural
mm,
uh, stuff. So not for so, so
mm,
but they are not really like they're not part of they are just like what we just what the only thing that we are just anything about
mm,
so like
mm,
external we are
mm.
working
Okay, okay. I mean, I'm sure that as people grow, you will have your own people working directly with you. Yeah, yeah. So you will need to know how to coordinate with them because there's always, you know how when we learned engineering in school, you learned about faculty courses, general engineering courses before they're specializing. So there's always areas of intersection. So there's a time you need to work with an electrical engineer and you need to like put heads together to like come to like a solution that works for the both of you, stuff like that. That's why I need to understand their own systems as well. So then, yeah, then another thing here is that as time goes on, innovation comes in, so you need to learn new things. So even if you are learning just maybe ducted now, you know the ducted systems now. As time passes, there'll be other more efficient ways of building, other more efficient way of integrating systems into buildings. So you need to learn about those methods and then just keep like innovating, yeah, and like basically
yeah
contributing to like a better environment. So there's this thing, entropy from our mechanical courses back in school. Your refrigerator constantly it, um, um, introduces a level of destabilization into the system because of the heat it releases. Yeah, and then the refrigerant it works with could be harmful to the environment too. So these are like some little knowledge that you can use. Then there'll be, I mean, over this week we'll have like some mini projects, but then we'll have like a final project to like cover everything that we've done. So now this today is just for me to like I'm going to do like a two-in-one today. Today was supposed to be like an introduction. Sorry, the first time our first meeting was supposed to be an introduction and understanding, yeah, which I've just done. So now we're going to go into the actual week one. So mhm. So we've already like I've already welcomed you. Shia, I welcomed you.
let's say
Yeah, yeah, and I introduced and all of that. and then we've done like an overview of the training program. Then yeah, so let's talk more about the purpose of HVAC in a building. So when you hear HVAC in a building, what does it mean to you?
HVAC. As the name implies, heating, ventilation, and cooling, air
Mm-hmm.
conditioning.
Mm-hmm.
So
There's no cooling,
it's
no. There's no cooling,
yeah,
no. There's no cooling in HVAC.
no air conditioning.
Uh-huh. Mm.
Just to create that atmosphere.
Mm.
Yeah,
Mm.
that is for parts, but yeah. So uh, it's like now different temperatures, different inspired different way of switching air. Like
Mm.
now in the cold environment, heat, then um, environment that is hot, let's say environment that is hot, you just require something like it's
Mm.
basically heating ventilation and air conditioning.
Mm. Okay. You what you said just now is just one aspect. So I'll give you a hint so I can talk about it. Ventilation soon.
Okay, ventilation,
Mm.
how like introducing fresh air, fresh air,
Mm-hmm.
basically
Mm.
fresh air, like making sure that there is a good amount of oxygen in
Mm. Mm.
the air. Oxygen. So
Mm.
that's for ventilation. I don't know if I got that right.
Mm-hmm.
That's an idea I have about
Mm-hmm.
ventilation.
Mm.
Then air conditioning, like um, you know, basically just um, let's say regulate air condition, like conditioning, like tweaking the air to
Mm.
satisfy to make that temperature complement
Mm. There's also humidity too.
two things, two under it.
I said there's also humidity aspect of it too under conditioning.
Okay.
Mm.
Okay, humidity. Okay, that
Mm.
is let's say how dense how dense the atmosphere is.
The amount of moisture.
Yeah, not sure. Yeah, that okay, let's humidity amount of water.
Mm-hmm. Exactly. Because HVAC is not a I don't think the term originated in Nigeria. So that is why you're hearing heating. Because why that heating is a bit strange is because in Nigeria we don't do a lot of heating. We do mostly cooling because of our temperature, our climate. But heating stood out here because in the US, because of the winter, heating is very important because people could actually die if they don't find a way to guard against the cold climate. Then ventilation has to do with the control of the air flowing into a space. Yeah. So I mean if you deal with only heating or cooling, it's like a refrigerator. So there's no exchange of air. And then human beings are in these spaces. And when human beings are in a space, they breathe in and breathe out. And that means there's some exhaust air that needs to be removed. Yeah, because they cannot breathe in that air that they exhaled already. So that is where ventilation comes in. So there's some chapters in that ASHRAE, for example, that gives you an understanding of the amount of air to introduce into a space based on the use of that space. So based on the number of people in that space, and then based on the use. For example, now a commercial kitchen, obviously need more air than than maybe an office that has just one person. So so it also enables you like in your equipment selection to and then your calculations to size properly so that you don't undersize or oversize. Then 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 sometimes too, another thing to consider and understand in this ventilation is if you remove entirely all the exhaust air, it's going to be very it's not going to be economic. It's going to be very costly to do that. So there's also like an understanding of like how to combine the return air. There's what they call return air. So the air that left the space can come back, can be reconditioned and then sent back into the space. Then based on what the space is used for, it um, can also introduce extra air, the quantity of extra air. It's just like a ratio thing basically to enable that the comfort is always of priority. Yeah, and then some spaces is not people that are there, maybe a data center or a library or a museum. It's used for like keeping some some items that need to like be kept at specific temperature and humidity. So there's need to control that temperature and humidity. You get. So then air conditioning is basically the control of that temperature and humidity and any other thing. Then there's also air quality too. Air quality is like it it deals with like the amount of contamination in a space. So a bathroom has like lower air quality than a room or an office. Yeah. Then a warehouse has lower air quality. So like you also need to like adjust how these things work to ensure that that space is fine. So now two of the systems we'll really like dwell on is packaged and split units. So packaged, I will need you to read up on these two, the difference between these two. I'll just give you an overview. So this is like your first assignment. Yeah. So at the end, I'm going to tell you that, okay, let me even write it here at once. Um,
I think I have an idea about
okay,
it.
tell me what
Okay.
you know.
So I don't. Okay. So probably packaged would be, let's say, like an example would be this window is
Mm,
have just have everything like spouse all the compressor, condenser,
mm,
sort of like everything in the mix.
mm-hmm,
Yeah, that's what I'm saying. That's basically what I'm saying. Like package is just as far like company like an AC. Because you know that window AC is like, you know, it's like a box.
mm,
It's the one part of its inside, then the other one just directly outside.
mm-hmm,
So so I split unit should be basically the ones that have the eye wall unit and the low wall units. So basically it's divided into indoor and outdoor.
mm-hmm,
Yeah, indoor and outdoor. So where the indoor, which is the
mm-hmm,
eye wall should have where the refrigerant go, where the evaporator, where the expansion valve, like in the outdoor should be where the compressor and the condenser basically. So where it's where the air in the room is has to like come in contact with those coils, those evaporating coils or something in the indoor units.
mm-hmm.
Go to the cycle, goes back. Yeah, I think I don't know if I'm correct, but maybe that's I don't know.
Yeah, you have a good idea. You have a very good idea. But I'll still need you to like read more on it and then you just write a short note on the two of them. Just a comparison. Yeah. Yeah, you have but you're not wrong. What you said is actually very correct. Packages they are together. Split is there's heat rejection and there's heat addition. All those things. Yeah. So basically, so you said it indoor and outdoor. So in split unit, the indoor unit is inside the space. The outdoor unit is outside. That handles the heat rejection or the addition. Yeah, depending on if it's heating or cooling. Then for package, that indoor and outdoor unit is together. So that is just in a summary. But I'll still need you to like just read up on it a little to just get better understanding because it enables you to know how to select also because depending on the nature of the space you may need to select this, you may need to select that. Then you also have mini splits. Mini split is very common in Nigeria. You know about it now, Shibi?
Um, no,
Are you
still
serious?
like kind of, still like kind of, but it's just it's, maybe I will have an idea if I
You
don't know something else. But
you probably saw it today. Probably saw it yesterday. Mini split is still split, but it's smaller. So this package and split that I mentioned are mostly for ducted systems. They are mostly for larger loads. Yeah, the mini splits are mostly for smaller loads, smaller systems. So, like for example, in a bedroom, in your bedroom or in your office, that AC that you see hanging on the wall, that's a mini split. Yeah, it is still split. It's still split, but it's mini because it is smaller. There is like there's like a larger of that kind of a thing. But that one usually works with like yeah with because that one is handling just a small space. There's no need to connect dogs to it to get because it's just going to point to that space. But the larger unit, which is just split, is usually needs to like condition more than one space at a time. So you can like control multiple rooms at a time or multiple like a larger space, which this smaller mini split cannot handle. Do you get? Mm-hmm. So that is just what makes all the difference. They basically work in the same principles. So it's just the scale. One is bigger than the other. So it means you know what it is like very well. It's very common. It's very common in like smaller projects. Yeah. And in our Nigerian space too. So yeah. Then next, some key components I'll talk about in HVAC systems is AHU. Do you know what it stands for?
AM, AM,
Yes, that is very correct. Yeah, air handling unit. Yeah, is like the name implies, it handles air. This unit basically distributes, it handles the pushing out of air. Like what I mentioned, that AC that you are seeing in an office or in a room is an air handler. It's an air handler because it it conditions the air. It that air conditioner you're hearing about, it does that to the air and then it pushes it out. So the distribution, the condition and distribution of that air is the basic purpose of the air handler. Yeah. Mm-hmm. Mm-hmm. Then then we also have FCUs. FCUs are fan coil units. So air handlers is a very general name, but FCU is like a subsection of air handlers. I mean, air handlers is the AHU basically. Air handlers, air handling units. So FCU is like a smaller subsection where it deals with is smaller. Is not like that mini split per se, but it's somewhere in between that mini split and split. It is still split, but it is a how do I explain it now? Let me see if I can Google it. It works with refrigerant also or water, yeah, and it's just somewhere in between, just somewhere in between a mini split and a this thing. It's just that I don't have to really put it, but a fan coil. Let me quickly look it up so I can use the right words. Mm. Or can you just look it up there and read it out to me so that you can get that understanding too? And then you can also see the pictures.
okay. It says is a relatively simple HVAC device that uses a fan to blow air over a coil.
Mm.
Which heats or cools the air for a specific space.
Mm-hmm.
Yeah. So it consists of a fan and a system.
Mm-hmm.
or commercial, residential, so
Mm-hmm.
like
Mm.
moving lights and spaces.
Mm-hmm. So yeah, so this is what it basically is. It's like it's somewhere in between. You know that mini split is mostly for residential buildings, but this it's like a simpler version of the air handler unit. Let's call it that. It's a simpler version. Yeah. So it doesn't have all the air handlers are a bit more complex than fan coil units. So so most times you use air handlers, but sometimes the client might ask you to specifically use a particular um, type of equipment. Yeah, this FCU now, there was a time that I specified an air handler, and then the client told me that he wants a fan coil unit. So I had to like read up on what it was and then do a sizing and all of that. So also there's still a lot of other different types of systems too. So there's also ROTU.
So you said the air handling is the general, like basically the general type, or let's say maybe this air conditioning system, like that's the general name.
Not general name per se. It is just the equipment. That equipment that handles air is called a air handler. There's still a separate equipment that handles the heating and cooling. That sometimes air handler consists of like heating and cooling coils. Those heating and cooling coils are connected back to like an outdoor equipment where the heating or cooling is done. Do you get?
Okay.
Like when the air flows over the cooling coil now, the content of that cooling coil increases in temperature. Do you get? So now that's
Yeah.
called that it there's like a cycle where it goes back to like the outdoor unit to go and release that heat it has collected. So this unit where that handles just the air that has that cooling coils and heating coils in it now is called the air handler. Yeah. FC is also a type of air handler too. Yeah.
So basically, it's like kind of still talking about like basically indoor units.
Yeah, it's like an indoor, but I don't want to call it an indoor unit because if in the case of a packaged unit, it is still part of it, but it is kept outside. But I'm calling it an air handler because it handles the air. You get so any part of your air conditioning system that handles the conditioning and the distribution of the air. Yeah, so it pushes out the air to the space it needs to be. That is called the air handler. Yeah, so this is just like a component of HVAC. That's just what this is. Yeah. Then RTU now is another system that that is packaged basically and it is placed on the roof or outside. This one is used mostly when there's no space to have like separate indoor and outdoor units. So that's when RTUs come in. They are called rooftop units. So they are made to like work with the weather. They are made to like to withstand harsh weathers. Yeah. So they are basically made to be placed outside over the roof. That's what I call rooftop units. But they consist of the air handler and the other outdoor units together. So there's also ducts. Ducts are you've probably seen ducts in like a big mall. Which city are you located in?
Because
Means you've seen ducts a lot now.
yeah,
Yeah. So there are different types of ducts, but their primary use is to channel air, either to supply air or to return air. Yeah. So so then you also have to they have like different types of cross section. There are some that are rectangular in cross section. There are some that are circular. Then there are some that are square too. Some are smooth. Some are flexible. Like that straw that is in all these small carton drinks, those children drinks. There's a part of the straw that bends. That place now that is ribbed, kind of. That's what a flexible dog looks like. Yeah. So so flexible because you can bend it, yeah, to fit into specific. But the other one is called a solid duct that you can't really move it around, but you just keep it in one place. Yeah. So I mean, over time, we are going to like you're going to see what it looks like. I mean, you can also look it up too to get better understanding. Yeah. Then diffusers or registers, they are like the endpoint of the unit of the ducts, like the point where the air comes out of.
Okay.
Yeah,
That is
on the
like
ceiling.
supply.
on,
Yes.
on the ceiling. You know that there is you know that just like how you have your bulb on your ceiling, all these recessed bulbs on your ceiling. uh Now that is where the light is coming from, but behind it there's wire connected to like the sockets. Yeah, so that bulb you are seeing is the light coming out. That is also like equivalent of like a register or a diffuser. So it is on the ceiling also. I mean, you can look it up. Just look it up so we can learn it together. Registers and diffusers. So you can see them. They are basically placed in the ceiling or on the walls or on the ground, but most times on the ceiling, depending on the location. So another assignment now would be for you to check registers versus diffusers, and then why are they placed, their locations, where they are placed, and then why. So yeah, registers, diffusers, or grills, where they are placed and why. Mm-hmm.
Let's just.
Okay. No, calm
Do
down.
you want me to? Do you want me
Okay.
to go into?
Okay, I didn't want us to spend too much time, Sha, but just give me a summary. But you still write on it. You still write on it. Yeah. Okay.
So, type of registers are grids. It's
Okay.
direction.
Okay.
Other fields are specialized to spread emission. Yeah.
Mm-hmm. 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 Then also, if you read further, you see that sometimes they are placed in the ceiling, sometimes they are placed in the walls, sometimes they are placed in the ground too. So you will just, I want you to like read up on all of that and tell me why they are placed in those places. Mm-hmm. So next, talk about, let me add it here. Okay, then heat pumps. We spoke about the air handler units. Yeah, air handling units. Now, heat pumps, if you remember from your HVAC and refrigeration um, classes, heat pumps, heat pumps are the part of the HVAC systems that deal with deal with the heat interaction. So this is like, it has some, you need to have like some knowledge of thermodynamics. Yeah, heat rejection, heat addition. So can you like describe what, okay, that will take some time. So let me just give you a summary, yeah. So of how cooling, for example, works. Yeah.
Okay.
With a vapor cycle, this thing of how cooling works. Let me confirm this. Give me a sec. Okay, yeah, it's called vapor cycle system. So it is used in refrigeration and in air conditioning, where it's for cooling. Okay, not it's for either cooling or heating, but let's talk about cooling. So yeah, you have, being that you're of mechanical background already, I don't need to like over explain. So you have the refrigerated space, Yeah. Okay, let's look at the refrigerator. That refrigerator space is the coolest part of this cycle or this system. Yeah.
Yeah.
So there's a coil in this space that does a kind of heat exchange to withdraw the heat from that space. Yeah. And then the coil now, the content of the coil is usually liquid at that point in time. Yeah. And when it extracts that um the refrigerant in that coil extracts that heat and then it boils, changes its temperature, changes its phase to gaseous phase, just like when water boils. So now, next thing, it goes to, give me a sec. Okay, it's as it does that, it goes to a condenser to go and release its um the heat it has taken. And the condenser most times is made up of a fan, just like in a radiator system of a car, a fan that blows over like that your outdoor unit. So you see that it releases hot air. Yeah, so that fan that blows over that space, that is where the heat that you absorb from the conditioned space is being released. And then it now like drops in temperature, drops in pressure, and then comes back to the space. So there is the compressor for increasing the pressure, and then there's the expansion valve for reducing the pressure. So this is just a rough estimate because I just believe that you understand what the cycle looks like. Yeah. You do understand the cycle, Abby.
Yeah, you
You do, Shebi.
yes, yes, yes.
If you don't, say it too, so that we don't go further than this.
No, I just heard.
Okay, okay. So you need to also read up on just to refresh also. So yeah, so now that condenser now is similar to a heat pump, or a heat pump is similar to a condenser because it is the part that handles the heat rejection. Yeah, so it releases the heat to the environment. Now, sometimes there might be need for heating in the space, yeah, in the conditioned space, yeah. So now, this system now that was going in a particular direction will have to reverse. So now, at the heat pump, now instead of releasing heat, it absorbs heat from the outdoor environment and then brings the heat into the space. This is mostly in like cold regions or cold environments or cold climates, yeah. So that is what the heat pump can do that the condenser cannot do. Yeah. So another thing that you read up on is condenser versus heat pump. Please add it to your please add it to your this and then just make a short note on it. Ah, what is this thing? Doing like this one. Okay, okay, okay. So yeah, so no need to dwell too much on that. Ah, what did they do this thing now? Okay. Okay, yeah. Then next. Mm, okay, we are already making progress. So this is we are still in like overall concept understand. Why is my mouse misbehaving? Oh, my mouse was misbehaving. That's why it's not working. Ah,
See, I usually like the wireless.
yeah, it's wireless. You want to lend me your own?
Mine is wired.
It does not matter now. You see that thing you see that thing we spoke about system giving up at the wrongest times. Now the battery won't die. But anyways, I have my mouse tracker, my mouse pad. And so as I was saying, yeah, so that's just basically like some little. Then there's also chillers. Chillers chillers are not always used all the time. They are not commonly used. Yeah, but chillers are like the name implies, they're used for cooling. So when you need to like take out air, when you need to take out heat, the refrigerant absorbs heat, it goes to the chillers and then it gets chilled or it gets cooled. Yeah. So yeah, I mean, we've already spoken about heating, cooling, and ventilation. So I mean, the whole point of this particular chapter was to help you understand that better. So next is cold water and hot water distribution. So cold water, the difference between Nigeria and US is that they don't, like I've mentioned before, they don't need to make their own borehole. Yeah, so you just connect. So part of what you understand here is sizing of the pipes and then the fixture the is serving and what again the the distance it travels and yeah this is your strong forte basically, so I don't need to even talk too much here. So then hot water,
can see for
yeah,
for
yeah,
can see
yeah,
can see opposite.
yeah, obviously I'm trying to see what I can add to this. Yeah, I mean, this is just an overview. You know, when we are like designing these systems, we are going to like talk more on it. So I don't want to like spend so much time here. Then hot water generation is a bit different the Nigerian system than in the US because Nigerian system it can be like water heater in a bathroom, serving only that bathroom. But in the US, it's different. It's a bit different. So you now have water heater like one water heater that is serving more than one bathrooms at a time. Yeah, so you need to like pipe the systems accordingly to like to take it to those places, and then you need to like take some precautions to ensure that they don't lose heat or they don't intersect with cold water or other types of pipes, all those things. And then you also need to like based on the temperature needed, there are um some purposes where some uses where the water needs to be extremely hot, especially in all these commercial kitchens and maybe health applications. The water needs to be really hot. So when you're like selecting your water heaters for those, you need to like select one that can handle such. Yeah. Then we also talk about drainage, waste, and vents. So sometimes they use septic tank, but that is not very common. If the client demands that you do it, but most times they connect it to the main sewage line. Yeah. So in this, so yeah. So then there's this thing called traps. It's usually in your sinks. There's and then your WCs also. There's this there's this part of the WC where it does not allow after you flush it, it does not allow air from the socket to escape back into the WC. There's this kind of U shape or S shape that traps water.
Yes,
Yeah, that traps like so that is basically what the trap basically is. So you need to like yeah, in a lot of plumbing fixtures, in a lot of sewage design, you will need to like understand how that works because if you don't get that right, the whole system can be a mess because that bad air will start entering the space and then contaminates the air and makes the place difficult to live in. So, so you as a designer, you need to specify this on your plan, and then so that those that are working on the site would also need to go according to it. Because if you don't specify, you think they will use their common sense, they might not, and then it's on you. You get. Then there's what they call interceptors. These are grease interceptors. Uh, Grease interceptors are mostly in like commercial kitchens. They capture because you know that grease is like oil, yeah, like thick oil, usually like a byproduct of cooking. So if you let it into the space, the the main sewage line, it could clog up those spaces, so or those pipes, and then it will cause a major issue. So in some kitchens, or mostly in commercial kitchens, there's need to specify that they add in a grease interceptor before the the output of the kitchen goes far and then contaminate the rest of the system. So next, um, yeah. So you need to read up on that as well. So next, fire protection. I believe I've even spoken about these things already. Yeah. So I mentioned NFPA. So I'll need you to like browse through the basics of NFPA, yeah, and just make like a short note on it. So any like whatever stands out to you, whatever you think is useful for fire design, you yeah. Then fire sprinklers. Fire sprinklers could either be wet, dry, or pre-action, but we're going to be working with just wet. So the dry or pre-action could be used when depending on the nature of the space. Pre-action, I think it's when you don't want the okay is mostly let me not spend too much time on it since you're not going to work on it basically. Then fire alarm, I mentioned it has to do with like notification systems and the detection systems. Yeah, the detection is like smoke detector or gas detector. Yeah, it basically detects like any like problem, and then it's connected to the notification system that releases either like sound or light to warn people that there's a problem. Yeah. Then let's talk about like project stages. So we'll not spend too much time here because you're used to this. So when we are designing, we will need to have like a picture in our head. You know that as designers, we are designers, yeah, like graphic designers, we need to have a picture in our head of what the system will look like before we do the system. Yeah. And to prevent back and forth, we need to understand what we want to do and to do it in the most efficient way possible. Yeah, we need to have like that big picture mindset when you are designing. So that involves like the concepts, yeah, understanding what the client wants and understanding what should be according to codes and requirements, and then finding the balance between these two. Because sometimes the client might tell you that to do something a certain way, if it does not follow the code, you as the engineer would say you reference the code where it says that this is not permitted or this is not allowed. You're the one that's a professional in this field. Yeah. And then you also come in contact with some clients that know what they are doing. They will be correcting you, but they're even correct. You get. So you need to understand how to understand what they want and how to translate it to your plans. Then in HVAC specifically, before you design, I mean, obviously there is in this design stage, you need to have like a rule of thumb of designing what the space should look like. Yeah, conditioning what the space should look like very fast. So, and we usually do that based on the area of the space. Yeah. So, for example, now the way I do the rule of the thumb for load estimation of the space is that um is that I take the area, the floor area of that space, multiply by 0.8, yeah, and then it gives me a value. If the area of that space was 500 square feet, yeah, I told you that the units are different, so we work with square feet and inches. If it's 500 square feet, we multiply it by 0.8. I hope you're writing this thing down.
Oh, maybe sorry. I wasn't
Ye-
waiting for purpose.
hmm. I shouldn't even be telling you. I shouldn't be telling you what to write down. It's you that would know what you think is important, so that you need to like, refer back to it. So yeah, so you take that
So,
area of 500 square feet, yeah, and you get 400, right? So on average, a space of 500 square feet will require 400 CFM of air. CFM is cubic feet per minute. That's like the airflow rate that's entering that space. So that's the amount of air you're producing, you're using to condition that space. So that's like a rule of thumb, very fast. So if the space is
so
bigger,
when it by 0.8.
yes, to
So
get the CFM.
I'm guessing 0.8 we should be from the first.
No, no, no. This is like a rule of thumb.
There,
This is a rule of thumb. It's a rule of thumb. Yeah. Now, when you this, I'm just saying this is like a concept. This is the first stage of design. Yeah. So this is just to give you like this is under preliminary load estimates. You're trying to like do an estimate of the load. Yeah. So this gives you an idea. Yeah. Now, the space now might be a space that has a lot of people in it, or it might be a space that has like a lot of equipment in it. So that was all those things will not like enable you to do the actual load calculation. You get, this is just an estimate. So yeah, the purpose of this rule of thumb is that it's faster and helps in case you need to like just look at the project and then just do the little math in your head. So this is what you use. Yeah, and then if the space is bigger, you can always get the floor area. Yeah, and then do this,
Yeah.
and you can have an idea of the amount of CFM needed for that space. Now there's a conversion rate from ton to ton to sorry, CFM to ton. So now that 400 CFM is equals to 1 ton. Yeah. So now it means that space that has um let me write it here. That space that has 500 yes times 0.8 equals to 400 CFM. Yeah. Now from CFM to 400 CFM makes 1 ton. 1 ton. Yeah. So now if that means if you have a space that the total square foot, the total floor area is like 2000, for example. If it's 2000, what would be like the tonnage for that space from what we have here now? Let me see how fast it can be.
It's too effort.
If it's 2000 square foot, 5 tons. Are you sure? How did you do it?
Yeah, I'm sure.
Tell me how you did it now.
That is like kind of like just multiplying. Oh, can you talk about square feet or we're talking
I'm
about CFM?
I said 2000 square feet. Why would I give you CFM? Will you get CFM when you are designing a building? You're the one that will get the CFM. 2000 square feet. That is the size of the space, the floor size. So, mhm.
That's for that's 1,200 CFM.
I thought you got 5 tons before. Okay.
Photo.
So, I mean, really fast, you can do that. You get. But now, we will need to do like a load calculation to determine the exact tonnage of that space. Yeah. This is in a lot of cases this might be correct, but it's not always correct because what load calculation helps you do is that it takes the climate into consideration. It takes the envelope. You know what a building envelope is? Building envelope is the walls, the roof, the ceilings, and the floor. What envelopes the building? So the type of materials used in those spaces. So when you're doing actual load calculation, it takes this into consideration. Then the use of the space, because the use of the space will tell you about maybe the number of lighting points, the number of people, the number of equipment, and that will give like the heating load and cooling load. Yeah. So when you do an actual calculation, it's load calculation, load sizing, it gives you something more accurate. Okay, another thing I forgot to mention is you can still see my screen, Abby. Okay. So another calculation of um ton is in BTU. BTU per hour is equals to 1 ton. This one is used mostly. This one now, this first CFM now is the airflow into that space. Then this second one now, BTU is the heating load. So it's the amount of heat per time that is removed or added to the space. Do you get? So now in further classes, we learn about manual G and manual N. So I'll need you to read up on those. Yeah, part of your assignment, by the way, Manager and Mama, and the difference and how they are used. Yeah. So they will not give you the and manual. Let me spell it for you. I think he's even here, Seth. I think I'll see it here. We'll even get there eventually. This is it. Manager and Mama. Yeah. So you just read. If I not clear that, okay. Okay. So yeah, you read about it, and with those things, you cannot get more accurately what the sizing of the space is. Yeah. And this will enable you to like select your your this thing. This one is mostly used, yeah, when you are doing like a rough sizing of um okay, let me even do it like this. When you're doing like a rough sizing of mini split. So mini split now, it does not really work with CFMs per se. It does, but you don't really control the CFMs as much as the inducted units, because you don't have like a duct where you know the area, because that area helps you to know better the amount of air that's coming out. Most times in mini splits, you focus more on the heating and cooling load. That's why I mentioned this BTU. So if you're doing like your rule of thumb for a mini splits, if you said that you're using a mini split for a space and you're trying to do like the rule of thumb, when you get to the area of the space and you convert it to tonnage, you now convert it back to the heating and cooling, which is 12,000, which is 1 ton equals to 12,000. Yeah, and that will enable you to select how many mini splits you need for that room. Yeah, sometimes it can be 0.75, which is 9,000, or it can be 0.5, which is 6,000 for really small rooms. Do you understand? Do you understand? Okay.
Well, sorry, you said something about converting it from that to ton.
Converting.
Converting it from like working for the units for working for the splits.
Mm-hmm.
I have to see the area of the unit like ton
Mm.
almost.
Mm.
Okay, before you know convert it to before converting it to per hour. Basically.
Okay, what I mean is that most times for mini splits, you don't really deal with the
Yeah.
CFM. More importantly, you design with the heating, because what you're doing is in mini split is you're just selecting the size and number of the mini split unit, the AC that is in that room. Yeah. So you don't really always focus on the CFM. CFM is the airflow. So I'm just saying that when if you decide to use a mini split for a space, yeah, based on like this is part of your design concept. You say, okay, I'm going to use a mini split for this space because it is like this. Yeah. If you decide to do that, you would now um do the size in this way. So you still do the normal area to CFM to ton, but when you get to the ton, you now convert it back to this BTU because you're not using the CFM. Yeah, yeah, yeah. But this BTU works for both systems, both ducted and and ductless. But most times in mini split, you focus more on just the BTU, not the CFM. Do you understand? Exactly. But it doesn't mean that you will not say no it too. It's just that you might not use it. Okay.
Right.
So let's moving on. Give me a second. You can still see my screen, Abby.
Yeah.
Okay. Editing in real time. So moving on. So the layout also. So when you look at the building plan, yeah, you would see where the windows are, you see where the door is, you see the height of the building. Yeah. Yeah, you see the height of the building. Then you see the use of the building, the name of the space. If it's a residential building, you have bedroom, you have living room, you have bathroom. So you would now in your mind have like an idea of how you would drop certain things. Yeah. Okay. Let me even show you um, a project that I was looking at. You're not seeing my screen again, Abby? Okay. I'm going to reshare now. Mm, can you see it now? Can you see it now? Okay.
Yes, I can.
Okay. Okay. Now I need my mouse now. Please beg my mouse to behave properly.
I beg you. I beg you.
Okay. So
I
now,
saw you say that that AutoCAD. Can I use AutoCAD too? Like,
uh,
or do I have to get into one?
well, I don't like to upgrade so fast because if you upgrade so fast, you could possibly miss some challenges that not only you get the challenges. So I mean, unless like my old um system or my old is no longer useful and I upgrade, or if I'm looking for something the higher version. But I mean, you can select the highest. It's just that this is what I've been using for a while and is what I understand. So I've not really upgraded to that yet. So I mean, if you are very fast with switching over, fine. uh So in this space now, you see that this is a bedroom, yeah, and then this is like the air handler, which is like an AC. This is not a ducted system. This is a ductless system. So this is the air handler, which is an AC. And I looked at this space and I decided to place it here. One, because I don't like to place it close to the bed. I don't know if it's a standard, but I don't think AC should be too close to the bed because if they are too close to,
I was even about to see if
it's a standard.
it's
Yeah, that's what I'm saying. I can't say for sure if it is a standard. Yeah, but this is just me using common sense because if it's too close to the bed, the person the person the person would, if it gets too cold, it affects the person directly, just like being directly under a fan. You get it? It's not very good health wise. Yeah, but it's not as if you put it close there's a problem. Oh. You can also research on it. You get, but this is just my own way of designing. So in this case now, I tried to place it here. Then then I decided to condition this. This is a bathroom. This one here. That this, if you see now, this is a ventilation fan. I decided to use this to condition the bathroom because I could not place one AC inside a bathroom. So one of these days we'll really look at this project and then we'll understand why I did it the way I did. But not right now. Let's ensure that we meet our time first. Okay. Ah, my mouse. Oh. Please beg my mouse for me.
okay. That's why that's one of the reasons why I didn't want to get wireless.
But it's very sweet to use. Oh. It's very sweet to use. But the one with wire sometimes you can have contact issue.
I
You
knew that. I knew that. Yeah, if I don't go
mm,
it's free and
mm.
everything.
It's just like wireless earpiece. You can see my screen now, ba? Okay. Okay. So now that is just like an idea of what layout looks like. So you have in your mind, okay, this is where I want to place this here and not here. So also when you're piping too, you know how where the pipe is going to run. You get those things. Like me, one thing I do is that I don't like my sewage lines to run. Like if he's leaving the bathroom, I like it to exit the house as fast as possible. I don't like when it is something is leaving the bathroom and entering like a bedroom and then maybe flowing through a kitchen. So I like to do it in such a way that it leaves the bathroom last because of the kind of solid waste that leaves the bathroom. You get, that is just one like the way I do my layout. So yeah, you assess the site constraints and building envelope. So this also helps in your building design, yeah, because some sites depending on the nature of by the time you look at the floor plan, you can have an idea of what this looks like. So maybe you find like maybe where there's what they call a site plan. Yeah, site plan shows you when where the water meter is, and that water meter is where you get your plumbing water from, your fresh water, cold water from. So you need to like when you're like designing the plumbing for a building, you need to connect from that particular point. You get. Then building envelope is also this is also part of help because you can't place how do I explain it now? If a space has like a very large glass wall or a large glass opening, that means that there'll be a lot of sunlight entering that space. That can affect the heating and cooling load. So this is how the building can also affect your plans. So now your design stage gone. After you've done the earlier assessment of the building very fast, your design stage now, you will now like do the actual calculations. So you produce your drawings, yeah. This is you understood in this design, the first stage where I spoke about this concept stage. This is where if you need any clarification, you ask the client, okay, why is this thing like this, and can I suggest this? For example, now there's the air handler is usually placed in a mechanical room. Yeah. So if you get an architectural plan and then there's no mechanical room and you want to put an air handler there, you can send it back and tell them, okay, please redesign and put in a mechanical room to get. Then if they not get back to you and tell that they cannot do that, you have to find like an alternative. But this first stage is where this concept stage is where you give your feedback based on like what you have in mind on how you design the space. Yeah. Then by the time you get to this next stage, you've already gotten all the feedback you want. So this is where you're like doing the final plans. Yeah. So in this stage, you also do your equipment size and selection, and then you also do your coordination with architects, structural and other teams, and then you ensure that your plan complies with all these codes, the necessary codes, so that you don't do rubbish. Because if you don't, it might be a problem later. Then construction stage. This now you might not always be there because you're in Nigeria and then the projects you're working on are not in Nigeria. So in this construction stage now, you would have to sometimes after you've submitted your final plans, sometimes comments come back. Either maybe the engineer on site or the engineer in they have what they call plan checkers. The plan checkers are like just like Ministry of Works. They look at the plans and then they decide if this plan works for this building and for this zone and for this city. You get. So this construction stage now is where all these things happens tend to happen. So you may need to like the plan may come back for it like make some changes which they will suggest to you. Yeah. But in all of this, you need to do your research back to back to ensure that you reduce the level of times it comes back. You get. Mm-hmm. So, I mean, you guys, you have some cases where you have been to the site, right? So this is where you supervise. This is like supervising. So in your mind, any project you're like designing, imagine that you're going to be supervising that project. Yeah. So that will enable you to like design like you are there. So you like ask questions and you ensure that this design is done properly. Yeah. Then next is the softwares you will use. You already know about AutoCAD, right? You know how to use it. You know about layer management, right?
I know how to use Revit small.
Than AutoCAD.
AutoCAD.
Oh, that is beautiful. That is very beautiful. Because yeah. So layer management. Okay, we are going to use AutoCAD more self. So and then before we get to Revit, so you will see all these things basically. Just remind me, this layer management, do you know about it?
No, no.
Okay, jot it down somewhere and then remind me maybe I'm looking at the plan. Then you probably have your at where you work now or at Eververse, you would have like templates. You need if you're the only one in your M team or your MEP team. Are you the only one there, or do you have like a superior there?
No, I have not school per se, but we all work together.
Okay,
But
okay.
I have people that yes, that we work.
That have more experience than you, so they'll probably be the ones to handle this because as a company, they will need to like present these drawings, and they need to have like, that they call title block back in engineering drawing. They're what they call title block, and they call like templates where you put your plans in to make it more presentable to look at. So I'm sure they will provide such for you. Yeah, yeah.
Okay.
Then I mean, if the need arises, I might need to look at it and then make some suggestions on how it should look like. Then the drafting command is like using AutoCAD, drawing AutoCAD. What do you do? How do you go about it, basically? Then Revit, you already know this, so no need to dwell on it. Yeah. So moving on. So I spoke about managerial man and end. So you research on what they are and how they are used. Yeah, and then subsequently over time we're going to like actually use them to do calculations so you see how it works. Yeah. Then also, aside from your drafting or drawing tools, you would also require some other tools like Excel. Excel, I believe you know how to use Excel.
Yeah, I do.
Okay. So not serious Excel, just basic Excel. Then you will need
Yeah.
to like prepare some reports or documents with your Word, Microsoft Word, or Google Docs. This one I'm using is Google Docs. So depending on what your team uses more, then you also need to learn how to like do markups on PDFs, because most of what you'll be doing, the output will be in PDFs. So you need to know how to like do some manipulation or some playing around with your PDF. And for this, I would recommend in Bluebeam. I don't know if you know about Bluebeam.
No, I don't.
Okay. Okay, Bluebeam. I didn't say beam, so
No, I said
okay. So you find and install it. Yeah. You already have AutoCAD and Revit, so that is fine. So you need to install Bluebeam because there'll be sometimes you need to like work with it. You probably have Adobe Acrobat, right? Most systems come with it. Adobe Acrobat.
yeah, okay.
Yeah, you know it now.
Come to buy.
Okay,
Yeah.
okay,
But I also this box it. I don't know which one.
okay. Is a PDF is this used for PDFs, for handling PDF? And well, as far as you know how to use it, there are just some basic things that you may need to like do on it. Yeah. So Bluebeam is the one I use. The one I use. I mean, by the time you see me you doing one or two things on it, you will just recreate it on what you know on your Fox. What did you call it? Fox what? Fox waiting.
Fox it.
Fox
Fox it.
spell abeg. Spell please. Okay.
Foxit.
Okay. Okay. Mm-hmm. Like this.
The reader. PDF
Okay.
reader.
Okay. Uh-huh.
PDF reader.
Okay. Uh-huh. So yeah. So I'll need you to read up on these. Yeah. Short quiz. So I've already told you these are the things you read up on. And I gave you some extra while we're talking. So please list out the ones I gave you while we're talking.
We said I should look up on manual two.
Mm-hmm.
Then I
Okay.
should look up on the basics of NFPA. I should read more on paper cycles system.
Okay.
Yeah.
Is that all?
Yeah, that's the many parts.
Okay, yeah.
History, then
Okay. So you just read up and then you write short notes on them. Yeah. Then you already installed all of these too. So and these two, I'll send you a doc sizer I will use for you to install. Yeah. So I mean this is not all the um softwares.
softwares.
Yeah, but over time I'll send you more that you install. Right. Okay, so I think we are already pretty much done with today's class, but before we leave, I just want to show you this plan. Yeah. Ah, Today that my mouse is not doing well. Okay. Oh, my blast say no be today go do this one or this mouse. Okay. Wait, let me go and get a battery. Time will not permit. Okay, it's working now. So yeah, this is a space where I did not use a ducted system. This is ductless. So
I'm
oh,
not seeing your
oh,
screen.
that is true. Sorry.
I'm just
Yeah, that is true. That is very true. Mm, okay. You can see it now, back. Mm-hmm. So now this should just give you an idea of the an M plan. This is like what an M plan looks like. Yeah. Okay, let me even do it this way. Um so I'm trying to print, then I'll preview it. Yeah. This is what it looks like when it has been printed out as a PDF. Okay. 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 If you notice, the main building is like in faint lines. Then the mechanical aspects are like in thicker lines. So this is like still part of what you knew about engine drawing. Yeah. So this is what you're like trying to call attention to, this the mechanical plans. Yeah. So you have the air handler, which is like an AC, those mini split AC. This is a mini, I use mini split to design this system. Mini splits. Then you have the ventilation fan. Ventilation fan is a fan that blows air, transfers air from one space to another. So in this case, transferring it from the bedroom to the bathroom. Yeah, because I cannot install AC inside bathroom. You get. But there will be some cases where you cannot do this. For example, like in commercial applications, maybe a restaurant. You can't do this in a restaurant. Yeah, because in a restaurant you have like higher hygiene standards. Yeah, so you have to find like an alternative way to like condition the space. So this is actually a very simple plan. Then you also have like above the WCs. Unlike in Nigeria, we don't really condition the bathrooms and kitchens, but out there they do. So this now is an exhaust fan that is placed directly above the WC. Yeah, this EF stands for exhaust fan. Yeah, and then in this it's usually exhausted through the roof, but in this case the client asks that I exhaust it through the wall. So that's why you see me like putting like a little duct system that goes out to the wall. Yeah, then this is what they call a kitchen range or a kitchen fan. Yeah, sorry, a kitchen hood. Range is like a gas cooker. Yeah, which is under, you can see it in faint lines. Yeah, then the hood is like is something placed above to like take out those hot contaminated airs that the is generated during cooking. Yeah, and then it leaves through these ducts here. So I mean, this in Nigeria you can find this in like maybe Kilimanjaro or all these big restaurants. Yeah, if you look closely, you might be able to, for those ones that you can see into the kitchen sometimes, or you can maybe like part of their preparation is like out for in the open. You can see that above any cooking equipment, you see that there's a kind of range, a kind of hood above it that sucks out the air. Yeah, then this is usually called a kitchen fan. This KF is just like the tag. Yeah. Then now this is another air handler. It's placed above a header. Yeah, this is a header. Yeah. And this is like a living room. In this case now, this is a small apartment where the kitchen and the living room are like together. Yeah. Yeah. So I conditioned it together. If you notice, this air handler is serving all of this space. But in some cases, if the kitchen is a separate space, it will have its own separate conditioning system. Yeah. Then you also need to learn
is
about.
there like like let's say I'm seeing like faint dash line
Okay,
surround kitchen.
okay, yeah. This is just something from, is a call out, an architectural call out. So it does not really affect the plan. It's just something that came in with the architectural plans that I did not remove. Yeah. So it does not affect anything. It doesn't affect anything. It's just like a call out. This is useful when maybe somebody needs to like it's just like when maybe you're looking at like a microscopic, when you need to zoom out on like a drawing, I need to like focus on one particular part. So this now, the architect called this out because there was a page where he like brought this area bigger for like you to look at. Yeah. So it doesn't really affect what we are doing here right now. You understand? Okay. So yeah. So this is another bedroom where I sent in. I gave it its own air handler. Yeah. Spaces like the living room and bedrooms would need to have their own separate air supply systems. Things like transfer, like you understand there are different types of zones, right? So there are some zones that you only allow air into, you cannot allow air out of. So I know I mentioned the return air one time, right? So return air is when the air needs to go back into the air handler to be reconditioned to come back, right? So in some spaces that are relatively clean, like an office, like a a bedroom or a living room, yeah, of like a small family, those spaces are relatively clean, so the air can be returned and come back. But there are some spaces where it should not be returned, it should be exhausted, like a kitchen or a bathroom. That is why in this plan, you have like the bathrooms have exhaust fan to remove the bad air because that air should not escape into any other space. Then in the kitchen, you have this exhaust fan over the main source. If you notice, they are placed over the main source of bad air. So this is to be exhausted from here. This dog goes into the roof and he leaves, no coming back. So in spaces like this, you have to also design with what they call negative pressure to ensure that air always flows into the spaces, not out of them. Because if the air in these spaces escape, they tend to contaminate the air of the other spaces. So this vent fan now, you cannot do it in reverse. If you notice, these arrows means that it must go in this direction, you get, not the other direction. So that means this bathroom now is the type of space is a space that air should not escape from but into, you get. Then another such space is also a garage. So that's why in these are spaces where you have air removed. In this space now, I used a ventilation fan to remove the air from the garage. In many cases, we don't condition a garage. We don't condition a garage. Garage is not a dwelling space, but this client requested that we condition it, so that's why I had to like put AC. Yeah, but in like 90% or more, we don't condition garages. Yeah. So if you notice, I even gave it its own separate AC and separate exhaust system so that it is like an isolated system on its own. It doesn't need to dwell with the rest of the building. Yeah. Then then pretty much this is just like a detail to show this is the outdoor unit connected to the indoor unit. So it's not drawn to scale, but it gives you like a pictorial representation of what it looks like. Yeah. Yeah. Then this is AutoCAD. We'll talk about this further in future. This is just like an overview of what we might do in future. All right. Then this is like what we call a detail page. It's called a details page. Yeah. So like there are some parts of the designs that you need to like give pictorial representations of. This is those parts to help the people on site understand better what you are drawing. And then this is like the schedule page. This describes the equipment on plan. So you see that you specify their specifications. Yeah. And then if you notice here, you have the notes. This is a Florida. This is in Florida. And then this is like the outdoor unit, the indoor unit, then the the different fans. There's an exhaust fan, there's a kitchen fan, and then there's there are ventilation fans. So all those things I stated them out here. Yeah. And then more information on the schedule. Yeah, basically. Yeah. So I mean, in our next class we'll talk about this further. So I think we have pretty much come to the end of today's class. So I don't know if you
Yeah.
have any questions for me.
Um, yeah, not for now.
Hmm.
Not for now.
So like I said, in this assignments, just do all these things and then we'll talk again by Saturday. Sorry, not Saturday, by Sunday, because today we've already covered two times. We've covered two classes in one today. Yeah. So next time I'm going to talk again will be on Sunday,
Okay.
where we move into the following week and then we start designing. Then next week we'll take classes. So I'm going to work with Sundays, Tuesdays, and Thursdays.
Okay.
So I mean, you have my WhatsApp number. If you have any um challenges, you reach out to me.
Okay.
And
No problem.
yeah, so this first period is just for you to like have better understanding. So you read up on all these areas I mentioned, and then so that when we are going into the design, we'll not need to dwell too much.